High-volume industries like telecom operate at a scale exceeding traditional accounting methods. These systems must ingest and organize millions of microtransactions every single day. Colloquial business language often uses the terms billing and invoicing interchangeably to describe the process of asking a customer for payment. Treating these words as synonyms overlooks the specific technical requirements of the SAP Convergent Invoicing environment. SAP addresses this complexity by splitting the workflow into two distinct sequential phases. The billing phase is followed by an invoicing phase. These phases handle entirely different data objects and rely on separate scheduling engines to prevent the general ledger from collapsing under high transaction volumes. This structural layout defines the complete consume-to-cash process flow, spanning from non-SAP external systems to contract accounting. Within the SAP ERP section, the architecture explicitly isolates the SAP Convergent Invoicing component. On the input side, external systems feed millions of rated consumption events into the billing stage for storage and processing. The ultimate goal of this pipeline is processing required postings into contract accounting on the right. Data does not flow through this system instantly. It is held back by target dates configured at different stages of the process. These target dates act as sequential floodgates, strictly controlling when raw usage data transforms into a financial posting. The foundational data unit in this architecture is the billable item, commonly referred to as a bit. Each bit represents a single rated event, such as a call detail record or a discrete download fee, holding attributes like origin date and rated value. As soon as a bit enters convergent invoicing, it encounters the first scheduling barrier. The system cross-references the bit against specific scheduling characteristics maintained at the contract account level. This process generates the first critical output, the billing target date, technically known as the bill first date. The bill first date dictates the absolute earliest moment that a specific bit qualifies for further processing. The billing target date functions as an internal aggregation tool. It allows the system to corral high-volume, erratic data into orderly batches before it ever touches the financial ledgers. A scheduling rule pushes a bit's processing date into the future. Here, Scheduling Rule 001 mandates billing at specific mid-month and end-of-month intervals. Bits originating between the 1st and 13th are assigned June 16th. The next cluster gets July 15th. During a background processing run, the system sweeps up only the bits that have matured past their assigned bill first date. These selected bits are fused together to create a new system object, the billing document. Creating a billing document represents a massive reduction in data complexity, turning thousands of individual usage records into a single consolidated record. This flowchart tracks the billing document moving into the pipeline's second half. After creating the bit and executing the billing run based on the bill first date, the billing document's creation triggers a second schedule determination via posting area 2606. The system now sets an invoice first date, representing the invoicing target date. The consolidated billing document remains in a holding status until this invoicing target date is reached. When the invoicing run triggers, the billing document is merged with other source documents to generate the customer invoice and post a receivable to the FICA ledger. This duality is essential. The billing date dictates internal data grouping, while the invoicing date dictates external customer presentation and financial execution. Maintaining two separate target date bottlenecks serves a critical architectural purpose beyond simply charging the customer. In a typical telecom contract, a predictable flat monthly service fee must coexist with continuous high-volume usage charges. Usage charges are generated continuously and unpredictably. The service fee, by contrast, is a single recurring charge generated on a fixed, predictable schedule. Business requirements dictate that both of these revenue streams must appear on one unified customer invoice. A dual-gate scheduling system prevents the company from sending thousands of daily micro-invoices, ensuring usage data aligns perfectly with the correct billing periods. The billing cycle is the mechanism that synchronizes these colliding data streams. The provider defines a strict period length and end date. For instance, the 5th of every month. The recurring fixed service fee is generated strictly according to this monthly cycle. This is contrasted by the erratic daily arrival of usage bits on various dates throughout the month. The system assigns a unified target date based on the end of the billing cycle, effectively holding daily usage data until it aligns with the recurring fee. The billing cycle acts as a temporal anchor. using separate target dates to slow fast-moving usage data so it can merge with slow-moving recurring fees. SAP Convergent Invoicing relies on these two distinct barriers to process two entirely distinct data objects. The billing target date provides the structure necessary for raw data organization and load balancing. The invoicing target date ensures synchronized customer presentation while protecting the integrity of the general ledger. This architectural distinction is a fundamental requirement for any enterprise-level system tasked with accurately processing billions of transactions. The system's true efficiency is found in its ability to selectively make data wait,